1. Physical and mechanical features of rocks. Physical properties of minerals and rocks. Rock density is the weight of a unit of volume without voids, pores and gaps. The volumetric weight of rock is the weight of a unit of volume in dry state. Rock tightness determines how well the rock absorbs moisture or liquids. It is expressed by the ratio of volumetric weight to rock density. Porosity of the rock. The presence of pores. Pores can be open, connecting with each other and the environment, or closed. The pores affect the gas content and strength of the rocks. Water absorption of rocks. Absorbability, the ability to absorb and retain liquids due to rock porosity. Isotropicity and isotropicity. The material environment is isotropic when the values of its physical properties are independent of the direction of the study. Continuity. Homogeneity. A material body is called homogeneous if its physical properties are the same at every point. Water permeability of rocks. The ability of rocks to pass, infiltrate water. Plasticity of the rock. The property of changing shape, bending, under the influence of external forces without causing cracking and maintaining the given shape after the cessation of these forces. 2. Rock deformation properties. Rock deformation parameters can be determined by uniaxial stretching and uniaxial compression test. The deformation properties of rocks depend on their elasticity and plasticity. Rock elasticity. The ability of deformed rock to return to its original state after removing the forces causing deformation. Plasticity of rocks. The ability of rocks to undergo irreversible deformations under the influence of external forces, causing deformation. Rock deformation properties can be described using the following indicators. Deformation modulus E0, a coefficient describing the rock's ability to deform under the influence of uniaxial compressive load. Ratio of compressive stress increase to longitudinal strain increase. Young's modulus of elasticity is a coefficient describing the ability of the rock to return to its original shape after removing the forces causing deformation. This property is tested when unloading the sample. The ratio of compressive stress decrease to longitudinal deformation decrease. Poisson's ratio. The ratio of longitudinal to transverse deformations obtained during compression of the sample in the elastic deformation interval. 3. Parameters determining the classification of the excavation ceiling. Floating of the ceiling, divisibility in the vertical direction, centimeters, a parameter characterizing the shoal structure of ceiling rocks. Identified as the average distance between all horizontal discontinuities and close to the level of both sedimentary and tectonic origin. Compaction of mineralized gaps, centimeters M2, a parameter characterizing the intensity of the occurrence of mineralized gaps in the excavation ceilings. Identified as the ratio of the sum of the lengths of all inventoried mineralized gaps to the analyzed floor surface. Degree of blocking, M2M, parameter characterizing the tectonic involvement of the region. Field. Identified as the value of the analyzed area per 1 running meter of the fault. Fault drop, M, a parameter characterizing the tectonic involvement of the analyzed region. Field. Identified as the average value of faults occurring in excavations of this region. Fields. There are 5 classes of excavation ceiling. Class I weak rocks, with compressive strength from 15 to 30 MPa. Class II medium strong rocks I, with compressive strength from 30 to 50 MPa. Class III medium strong rocks II, with compressive strength from 50 to 80 MPa. Class IV strong rocks, with compressive strength above 18 Pa. Class V very strong rocks. 4. Strength properties of rocks. Rock strength is the limit value of resistance to external forces by the internal forces of this rock. When the endurance is exceeded, it is destroyed. Stress is a measure of strength. Rock compressive strength, RC, the force causing crushing, compression of the tested rock sample is measured. Appropriate tests are carried out in the laboratory, subjecting the rock sample to crushing in a hydraulic press. Tensile strength of rocks, RR. It is resistance to the effects of forces trying to tear its coherence. The size of the bursting force is expressed in N/M2. The test strength for all rocks is several times lower than the compressive strength. Shear strength at T. The maximum resistance of the rock to tangential stresses occurring in the shear plane, the plane in which there is a relative displacement of one element relative to the other. Flexural strength RG.